Welcome back, everyone. Today, I'd like to quickly introduce an approach called TDD, or test-driven development. While this technique falls under the realm of testing, it's more helpful to think of it as a software development technique. And it's exactly what it sounds like, writing software that's dictated by tests. There's some pros and cons to this approach, but I will discuss them after I demonstrate what TDD looks like, so it'll make a little more sense. Let's work with a common question that you might see on LeetCode or Code Wars or Codekata or any of those other platforms. And this one has a couple of potential solutions. So basically, you want to write a function that takes in a word and tells you whether or not the word is a palindrome. So if you don't know what a palindrome is, it's basically a word that's spelled the same backwards and forwards. So race car is a palindrome, okay? And this is not a palindrome, okay? Basically, we have our boilerplate set up here. We have our skeleton of a function. We're exporting it, and then we're going to import it in our test file, and then describe is palindrome. Yep, we have our describe block. So basically, let's talk about the steps of test-driven development, okay? So TDD is broken down into 3 steps. The first step is called red, okay? And this is where you write your tests. And the reason it's called red is because it is supposed to fail. You notice how every time you get a failing test, it shows up as red on your terminal? That's why it's called red. And so the next step is going to be green. And you can probably imagine why it's called green based on what I said earlier. Okay, so this is the part where we write enough code to make our tests pass. And then the third and final step is going to be refactor. And this is basically just, clean up, getting rid of any comments, any console logs. So clean up. And more importantly, it's also where you start thinking about things like optimization. Let's start with step 1, write your tests. And this is the part where you really have to think about what your output is going to look like, okay? So let's do this. So I know in the previous videos I wrote it instead of this, but this works exactly the same way. I'm just gonna do it here just to prove that to you. So it should return true if race car is passed in, okay? All right, so we're gonna say expect is palindrome race car to be true, okay? And then the other case that we are looking at, because there's really only 2 cases that we're going to think about. There's probably going to be more, but for the sake of simplicity, we're just going to work with 2 cases. All right, so now this should return false if this is passed in, okay? So, great. We wrote our tests. We're just going to delete that step. And actually, let's go into jest, make sure that we're getting the expected result, and it looks like we are. Yep, they're failing, which is what we want, oddly enough. Yep, we're receiving undefined, which makes sense because there's nothing happening in our function, and it just returns undefined if it doesn't return anything. Okay, so now let's move on to this step. Green, write enough code to make your tests pass. All right, so I'm gonna purposely do this a very inefficient way, okay? So that we can talk about refactoring. So what I'm going to do is I'm going to take this word, I'm going to create a reverse of it, and then I'm going to compare the reversed version with the original, and if they're equal, then that means it's a palindrome, and if it's not equal, then it's not a palindrome. Yeah. Okay, so I'm just going to do this in one line to make this very simple, well, fast. Const reversed word equals word dot split dot reverse dot join. and I think you have to do that. I'll just move this over, yeah, so that it's nice and readable. Okay, so now we're just gonna return reversed word equals the original word. And basically just like return, like if these are equal, it's true. If not, return false. So now let's type in jest and let's see what we get. Yay, it passed. All right, so that means we have finished this step. Awesome. All right, so now let's talk about refactoring, optimization. We don't really need to clean up. We didn't really do much here. So like I said before, this is inefficient because what you're doing is you're turning the word into an array, and then you're reversing the array, and then you're turning the array back into a string, and then you're seeing it that equal. That's a lot of work. So we're going to do this in a way that's a little more verbose, but is actually more efficient. So we're going to do let start equals 0 and end equals word.length -1. So basically what I'm doing here is I'm creating 2 pointers. So this is start, this is going to be the beginning of the word, and then this is going to be the end of the word. All right. And so we're just going to check to see if these letters are equal, and then we'll just kind of close in. And if we keep closing in and we made it to the middle, then that means the word is a palindrome. And if it doesn't make it there, that means it's not. So it's much faster. So now we're going to do while start is less than end. It could be less than or equal. We'll have to figure that one out. So now while start is less than end, we are going to check to see if the letters that they're pointing to are not equal. If they're not equal, that means it's not a palindrome, and we can just end the function right there and just return false. So we're going to go if word start does not equal word at index of end, then return false. Okay. And so if that's not the case, then what we can do is increment start and decrement end. I mean, this makes sense. Like, there aren't that many palindromes out there, to be honest. All right. And then we are going to return true, because if we made it to this point, if we broke out of the while loop, that means this is true. All right. Actually, I think it's going to be this, so that way it can work with odd. No, whatever. All right. So let us run this and let's see if it worked. Yay, it worked. So that means we can get rid of that. Whew. Sweet. So there are a couple of pros and cons to using the test-driven development approach. So the obvious pro is that we are figuring out on the right before we even write a single line of code, we figure out what our code is supposed to do and force it to kind of make it modular. And this is very handy if you're working with very complex functions. It kind of points out where you need to break up functions as you write them. That might not be so obvious with such a contrived example here, but if you work with more complicated stuff, this can be quite useful. Of course, having tests for everything will ensure that your code remains robust. Okay? So now some cons to this approach is that it can be quite time consuming. If you're working in an environment that's very fast paced and you just want to get something out the door so that users can try it out, testing may be a waste of time. It really depends on what kinds of features you're writing, but it can really bog down a team's time. And also, this is not necessarily beginner friendly. It's something beginners can do, but it's something that also requires a lot of discipline to stick to, and that's something that comes with years of experience. And it also assumes that you have a pretty thorough knowledge of best practices for testing already, because your entire project is hinged on your ability to write good tests that are useful for you. So that's all I have for now, and thanks for stopping by. I'll see you next time.